Okay. We already
Hello.
have a few people in the audience. Hi, everyone. Hi, Ricardo. Hi, Adrian. Yash. We'll take just another minute to let everyone join in, and then we'll get started. All right, a lot of people coming in. Keith, Cody, Bill, hi, welcome one and all. Vikas, Varun.
There's two. There's two Varuns.
Oh, it's a replica set.
While you all are rolling in, why don't people tell us where they're coming in from? Which part of the world are you from? I'm from Toronto.
We are from Tel Aviv, but coincidentally, Nikki over here is also from Toronto.
Bridging the gap.
Yeah.
I love it. Love when we have more Canadians, more Canadian representation.
That's right.
I bet we have a few in the audience as well. Hi, Kevin. Hi. Vikas, Wojciech. Bye, Wojciech. Oh, sorry, I mispronounced your name. Okay, I think we're ready to go. So, hi everyone, and welcome to our monthly webinar. Today we're going to be discussing continuous Kubernetes reliability, what this concept means, and how to achieve it using the right tooling and methodologies. And to teach us all of that, we have the one and only Marino Wijay. Is a solution architect at Komodor, co-organizer of KubeHuddle, founder of MTTR, Sivo ambassador, and newly minted CNCF ambassador, and an awesome human being and a dear friend. I'm Udi.
I'm Nikki.
And before Marino takes us on this reliability adventure, just a quick note. If anyone has any questions throughout the session, please leave your questions in the chat, and we'll have time to address them either mid-session or at the end. Throughout the session, we'll have quick polls. Super easy. Marino will walk you through it, but be prepared. And finally, we will have a hands-on demo of Komodor, and you are all welcome to follow along if you want to start using Komodor for your reliability optimization. Marino will show you how. So without further ado, the man of the hour himself, Marino, take it away.
Thank you, Nikki and Udi. I really appreciate you both setting this up. I mean, it takes a lot of work to run any kind of event. I mean, coordination, making people aware of the fact that there is something coming about, and just being very continuous about it. So massive appreciation for you both. Round of applause for them if you're in the audience. Thank you, thank you, thank you. Well, hello everyone. Thank you for coming out to this webinar. My name is Marino Wijay. I am a solutions architect here at Komodor. And we're going to talk a little bit about continuous reliability. And I'm going to go ahead and share my screen. As you are all just listening in, feel free to share, some of the challenges that you've been facing when it comes to reliability in your own environments. And at the same time, if you've got any questions about Kubernetes, around some of the tools that you've been using, feel free to, ask away and we'll be happy to answer them. So again, my name is Marino Wijay. I'm part of the Komodor team here, and again, an organizer for KubeHuddle Toronto, also a CNCF ambassador. And I've been part of the CNCF ecosystem for quite a while. So there have been a number of different areas that I've contributed to, either the Cilium or Istio projects, and even Kubernetes from way back. And I've just been a part of the community. I love working with the community as much as I possibly can. So let's talk a little bit about reliability. And just to set the context and agenda here, a conversation I had a while back just brought up this idea that load balancing seemed to solve all reliability challenges, or a good chunk of them for that matter. And that's partially true depending on how you look at it. With the case of balancing loads or load balancers, we have this system that pulls a bunch of like resources together and effectively distributes the load, a request, access to resources so that you don't have a single entity or single resource that's responsible for being able to provide that response. The problem with this is it's not a model that truly addresses all aspects of reliability. And so when I kind of posted something on social media about this, I got a response from one of my really good friends, Dan Finneran from Cisco/Isovalent, claiming that load balancing is the way. Load balancing must be the way. And it's funny because he actually did create a technology called kubefit, which is utilized in a lot of different environments for protecting the Kubernetes control plane, in addition to providing services of type load balancer as well, and then other load balancing capabilities. Now, before we dig into it, I actually want to ask a few questions, and we're going to do a quick survey. And so I want you all to participate by heading over to Slido. Hit that QR code there, scan it, and then I'm going to go look on the Slido end to see what's going on. I want to see a bunch of responses come in as I start the slide. And you'll also have access to be able to, launch that survey again. The QR code will show up when I click off the next or kick off the next question or the actual question. So the first question is, what does reliability mean to you? And for folks, if you're listening in, feel free to scan that QR code and, add your words, right? So the way it works is you're just coming in here and thinking the first thing that comes to mind, right? Whatever it is around reliability and incidents, just throw it up there. And I'll give us about a couple of minutes to throw some words up there. Maybe I should even participate too. Let's go ahead and scan that QR code there. If you can see me scan my QR code, and let me see what words I can throw in here. Uptime. I'm gonna throw in another one. I'm gonna add a response. Disaster recovery is my word. Okay. Okay, let's see. I know there's a few more of you in there. Feel free to add your word. Don't be shy. Add more words. It's totally fine. Okay. All right. On to the next one. Well, we have one more. I'll show it later on. Oh, I love that. Uptime. Uptime is the key word, right? We want to make sure that our systems are always available. And we want to be a little bit more confident that our systems will always be available and provide that uptime. There's a lot of considerations, though, when it comes to achieving that level of reliability. So we're going to dig into it. And I'll be honest, the list that I'm about to show you is not exhaustive. It's not the be-all, end-all of reliability. It's just some of the things I've seen over the years that add to the reliability metric and things we should be considering as we work to achieve that continuous Kubernetes reliability. So let's start with the consideration around right-sizing our workloads. Many, many, many years ago, back in my ops days, when we had developers that wanted to deploy and test applications, they would reach out and say, hey, I need a system, a server, Windows, Linux, whatever it is, give it to me because I need to be able to test this application. Back in 2008, it was Windows. Windows did a lot of interesting things for us. And so it wasn't so easy to just hand over the right sized system to that developer because I'd have to call into a server seller of some sort, someone who would sell me whatever kind of servers that I'd want and with various capacities. And then I'd have to procure it, get it shipped over. I'd have to image it, put an operating system on top of it, patch it with all the right updates, and then put it on the network. And then once it's available, I'd share credentials with that developer, and then they'd go about using it. Problem with that, though, is they wouldn't always be using that server. They'd be using it maybe for the hours that they're in the office, and then they'd be using it for, testing. And it wouldn't even consume all available resources. Back then, one CPU and a gig of RAM was a lot to a developer, and they'd be able to do quite a bit. Maybe they'd ask for more. I mean, realistically speaking, I wouldn't buy a server with that much amount of capacity because it just wouldn't make sense, especially since back then you could probably get something that had about probably 4 cores of CPU and anywhere from 32 to 64 gigs of RAM that would do quite a bit, except there'd be idle capacity. So what you have is a situation where you have all of these servers and unused capacity. When you think about that for a second, and you think about today in how we inefficiently use Kubernetes, for example, we just deploy clusters and then we pick namespaces and then we'll just deploy workloads. We're not truly right-sizing them. We're not putting in the right guardrails to ensure that they're only consuming the right amount of CPU and memory when they need to. And so you're avoiding the game of Tetris because maybe you're scared. And so we need to revisit that and think about adding reliability by the way of, succeeding at the game of Tetris when it comes to workload adjustment and right sizing. Now, there's another element to consider around policies and guardrails. And it's not just about creating a firewall policy that says this network can't talk to that network. It's actually a lot more than that. It's the idea that you haven't disabled root access to your nodes across your cluster. And if it so happened that a malicious workload made its way into your environment, it has the ability to take it down and cause a potential denial of service attack. So now you're left there trying to figure out what caused it, how to ensure that it doesn't happen again. And you learn from your mistakes, and now you implement the right guardrail that disables root access to the nodes. That's one example. And the very classic example of back in my Active Directory days is, hey, I need local admin access to this system that I own, but also my account needs admin access to a number of other systems. Now that's dangerous, right? When you have admin access to a number of servers, there's a lot of things you can do. You have a lot of unlimited power, so to speak. So you actually need to do the reverse and address that. Again, the level of access that you have, role-based access control, is one form of the way you go about addressing guardrails. Reducing service latency is an interesting one because way back in 2008, we didn't have access to fast circuits. 100 meg internet circuit to your office or to your branch location was a luxury. A gigabit to your data center was a massive luxury. In fact, you'd literally be paying a significant amount that would probably cost way more than your servers would if you were to break down that into a monthly cost. And you had to mitigate your latency in various ways. And you would use tools like flow control and quality of service configurations at your network level to help with that latency. Didn't always fix the problem because latency affected things like voice over IP and video calls and even, for example, the way you would achieve disaster recovery. Disaster recovery is an interesting one because if you haven't synchronized your storage across to your backup location or your secondary location, and it's because that synchronization is affected by the level of latency you have, which is high on the wire, well, your disaster recovery plans are not going to succeed because you're not synced up when it comes to storage. That was actually a problem way back when. We can address that now in so many different ways because we have WAN optimizers, we have high-speed circuits. We don't necessarily put all of our data into one particular location. We spread it across the various locations to reduce latency or reduce the latency to access because we want to be able to be closer to our services. And just a variety of other considerations as well. By the way, if you have questions, feel free to pop them in the QA, and we'll be happy to answer them for you. Don't be shy. I will take any question. Now, there are a number of ways to reduce service latency today. If you're thinking Kubernetes, well, right-sizing workloads is one way because you obviously don't want to starve your workloads from the resources that they need. And if they're having to fight for resources, well, that will increase the service latency because that particular service is in path of that request. So you could use tools like maybe Service Mesh to help with that. Now, there's another element too, especially when it comes to reducing your mean time to recovery or mean time to repair, your MTTR. And I've even listed it down further around like ways you would strategically reduce that. But here's one, right? Reducing your tooling and login fatigue. You have so many different tools to try and discern when there is an issue that you actually haven't had the opportunity to figure it out in your acceptable level of time. And that's just because you're having to hop through different systems. Oh, wait, you forgot the password for one. Oh, well, we've got password management. That should help solve the problem. But that doesn't help with the fact that you still have all of these independent data sets and data sources of data telling you what's wrong that you have to comb through, like finding a needle in a haystack. You have to comb through all of these different data sets to actually find what's going on. Way back in 2008, same deal, right? I'd have an Active Directory account to be able to log into AD to see what was going on maybe in my DHCP and DNS servers. That was part of the problem. If I needed to log into my Cisco firewalls and routers and switches, I'd have a separate set of logins because I probably didn't have Radius configured. For those that aren't familiar with Radius, it's just a protocol that was used. Actually, Cisco has their own, it's called TACX. It's a protocol that's used that ties authentication into, let's say, Active Directory. So you could use your Active Directory account to log into these devices. Federation wasn't like truly figured out. SSO, single sign-on, wasn't truly figured out. We are there today. And so we want to take advantage of all mechanisms to be able to reduce the amount of times we have to log into different systems. Heck, we don't even want to have as much tooling to log into. We probably want to consolidate that even if we can. Now, there's an element of being a little bit proactive. We have different ways and different approaches by which we, look at our code and maintain it, make it better. And even the same applies to our systems, the way we patch them and the way we upgrade, let's say, clusters. The problem with something like that, though, is when we have different systems, they're not all going to be in lockstep. So a long time ago, when I was at a company called Dell, you might know the company. They're pretty big. They sell a bunch of computers, but they also sell servers and stuff. On the server side, they had all these different components. They had cables, they had interfaces, they had switches, they had servers, they had RAID controllers, storage arrays, a variety of different components. And not everything worked together. It's not like you simply plugged and prayed that it would work. There was a lot of validation that happened behind the scenes. And so there was a team out there that maintained something called the compatibility matrix. And that matrix was so important because if you were ordering something on behalf of an end user, you would ensure that if you were ordering this type of cable and it had to go into this type of server or switch, you have to go cross-check that. You have to validate that this works. There are systems in place that validate the bill of materials today to ensure compatibility, but we were doing that manually way before. Now, we've kind of fallen off of that a little bit in some sense because there's configurational drift, there's version drift. Heck, when we actually upgrade Kubernetes, our CRs, our custom resources can break because we're running Istio, we're running Cilium, we're running Argo, we're running Cert Manager, we're running all of these additional components like Kafka, and they all operate along a single set of like versions, right? They'll all operate together cleanly with a single set of versions. But once you change one, let's say you change Kubernetes, a bunch of them tend to break. And so you have to keep up with that and keep afloat so that if you do change Kubernetes, because guess what? Kubernetes does reach end of life. You want to be able to update your other resources as well in lockstep. Now, again, here's the thing though, you also have to consider if you're operating different platforms and you're trying to consolidate everything, you have to consider that you also don't want to consider proprietary situations or solutions, in the sense that one single solution or one single API can cause reliability issues as well. If you built a single API to access all of your workloads, and if that one API breaks in the way you actually deploy or access or make changes, well, that's reliability in itself. And so as you start to think about reducing MTTR, you have to consider capacity. You have to consider the way you address your guardrails. You have to consider the right sizing aspects as well. And you have to be proactive with your maintenance cycles. Now, there's so much more to consider. The infrastructure piece has been figured out for many, many years now. If you are looking to deploy and use infrastructure, it's easy. You can go to the cloud, deploy it, and choose it and run with it. But DNS actually tends to be a very interesting piece too, because it's tied very well with the network, and it's tied with the infrastructure that you use. It's tied with the load balancers that you use as well. And if DNS is not functional, a lot of things can break as well. And DNS, as simple of a resource as it could be, is also a very critical resource when it comes to reliability. Now, this element around retries, resiliency, and service invocation is actually when your applications need to do a lot of the work as well. There's only so much you can do at the network and infrastructure layer to help with some of this, to help with your applications when a request fails and helping it retry that request, or when your application fails and you need to find a recovered or a backup of that application somehow and still connect to it. Service Mesh re-enters the chat and can solve that particular problem. There are technologies like Istio and Cilium and even Kuma Mesh that are, or even API gateways for that matter, that are helping solve this particular problem because they deploy proxies at the service level and do a lot of the connectivity and proxying of those connections on behalf of that service. So it's the service itself doesn't even have to think, and it offers a level of flexibility so that you can even achieve things like your proactive maintenance in an easier sense. The final thing I'll leave you all with before I shift back to a survey is around the consolidation of all your platforms. So you have a platform to view the network. You have a platform to view Kubernetes. You have a platform that just has a bunch of logs and it's just a log sync. You have a platform that tells you the health of your cloud environment. But you don't have a platform that really consolidates your Kubernetes dashboard and gives you the reliability capabilities as well. And that's where we need to go, especially if we're thinking along the realms of continuous Kubernetes reliability. A platform that simplifies it all is what we're after. Because sometimes when we're trying to pinpoint an issue very quickly, or maybe we don't want to become Kubernetes experts, well, we need something that simplifies that experience for us. So, survey time. How many reliability incidents have you had in the last year? It could be related to Kubernetes. It could be related to something else, something to your cloud environment. Go hit up that QR code, and I'll give you all a few minutes to maybe share some of your own thoughts and share how many issues you might have run into over the last little while. And don't be shy, right? Look, this is an anonymous survey. It just helps us understand, how many incidents you're running into on an annual basis, and if you've actually got that under control. Heck, I'll even participate and maybe talk about some of the incidents that I've caused and whatnot, maybe throughout my career. Maybe in one particular year when I was doing some consulting work, I've definitely hit the 1 to 5. Okay. Give it a couple more seconds. Do a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So about 70% of you have had about 1 to 5 incidents in the last year. I don't believe you. I think you're probably not telling me the truth. Let's chat afterwards. Feel free to reach out and we can chat a little bit more. But I also want to say that, sometimes the problem may not be DNS, or we might believe that it's not DNS, but in actuality, it's always going to be DNS. In fact, a lot of the issues, a lot of the incidents that I have run into many, many, many years ago, and even today, even more recently, has a lot to do with DNS. Some of the biggest failures we've seen in the global internet space have been tied to DNS as well. So interesting stuff to see. All right, I've got some more slides I want to show you, and then I'm going to show you a brief demo, and we can get to some QA as well before that. But I want to talk a little bit about where we've gone with Kubernetes. Like we've actually gone beyond the, hey, I want to deploy my first cluster with kind, with 3 nodes. It's going to have no CNI. And we're just going to like run Nginx and see how it works. But we're not there anymore. We've gotten way past that. We've been using Kubernetes at scale across the on-premises data center environments, at the edge, in the cloud, maybe on your Nintendo Switch if you manage to mess around with it and hack away at it. There's so many places that you'll be surprised where Kubernetes can run and what it can do, especially when it comes to automation, smart home automation. And I've been like thinking about like what I can do with my little home lab here and get to a level of, hey, let's use Kubernetes to run my house. I don't think I'd actually ever get to that level. But when you think about the scale at which we operate, if you think about the additional tooling we have to put on top of Kubernetes, because it's not complete, it's not a batteries included solution or platform. There's so many moving pieces, from using a service mesh to using an API gateway to making sure that we've got our ingress running, to making sure that we've got some sort of policy engine in place, to making sure that we've got some cluster manager that scales our clusters up, to making sure that we've got databases, if we want to run them in Kubernetes, operational. There's so many different moving pieces that we cannot just say, hey, Kubernetes run and you're going to be on your way. We have to be a little bit more cognizant of the moving pieces here and accommodate for the moving pieces as necessary. So imagine you were running Kubernetes, right? And you were using everything you can think of when it comes to that CNCF ecosystem, or that, that massive landscape that you can think of. Let's pull up that survey again. After an outage occurs, what do you actually feel? What are your emotions? How do you feel? What's going through your mind at that time? Because the reality is, like, we sit here and we think like, I could have done it differently. I could have prevented something. I wish I had this. And most of the time it leaves us feeling, vulnerable in some sense or some way. I'm gonna actually add to this too. I'm gonna throw out my own feelings as well, because yeah, what happened now, right? I'm going to say I'm going to feel. See, my word is defeated. Sometimes when something happens, I feel defeated. Another response. Sometimes it could be, I don't mean to overly joke, but it could be an RGE, right? Or it makes you feel like it could be an RGE. And so you have to think about, okay, well, what could we have done to prevent that? How could we have been a bit more proactive? How could we have consolidated all of those data sources and made it simpler for us to be able to solve that problem? Yeah, there's a lot of feelings that we feel when an outage or an incident occurs. And sometimes we take it personally too, because it feels like a reflection of our own failed system, right? Like, we own the system. We should have made sure that we should have done better. But I'll be honest, like, there's a flip side to it. It's actually down to a broken process and broken software at times. There are bugs in the system that we can't control. We don't know when, a table is going to be overwritten to, or we're going to run out of storage at times, but we can be a little bit proactive and have a lot more awareness to that, and maybe some historical data to help us plan a little bit better. So how do we do this? How do we handle this? Well, if we want to achieve some level of reliability management and help with the troubleshooting and not be Kubernetes experts and have Kubernetes superpowers, well, we need something. We need a platform, a very flexible platform that allows us to tie all of these pieces together, to correlate all of this data and tell us, hey, your Kubernetes cluster is going to reach end of life. well, you better start checking these CRs. And so that solution is actually the Komodor solution, the Komodor platform. And I'm going to show you a little bit of that Komodor platform. We're going to jump into a little bit of the environment and see the different approaches that we can take to add to the reliability metric and even just improve upon our troubleshooting skills. So before I flip over to that environment, if you have any questions, right, feel free to bring them up right now. I'm more than happy to answer them. I'm actually going to check the QA myself. I don't see anything there. I see nothing in the chat as well. So I'm going to go ahead and share my screen. So what I'm actually sharing with you right now, and if maybe Udi or Nikki, if you could just maybe ping me there and let me know that you can also see my platform here, my Komodor screen.
Your screen.
All right, perfect. All right, let's keep going. So you've decided that you want to dig into Kubernetes at scale, and you have all of these services, and you want to add everything together into a single platform. Well, okay, we've gotten past the first step of onboarding all your clusters into Komodor, and now we see all of these different services. And because we see all of these different services, we begin to realize, well, this is too much data for me to comb through at the moment. I need to narrow this focus down a little bit more because, I've got different teams. And if I'm really trying to allow them and enable them to be a little bit more independent, self-serving, and solve Kubernetes problems on their own, well, they're going to need to be a little bit more scoped down a little bit. So one of the cool things that we do at Komodor here is we have a feature called the workspace feature that helps us scope down all of these different services. And we could do this and slice this up either through a namespace point of view. We can pick individual resources in our clusters. We can pick clusters. The boundaries are limitless in how we decide we want to create a workspace and scope this down. But then this allows us to tie it to a model where I've got a team that just focuses on a set of services, and they need to be responsible. They're service owners, right? They need to be responsible for the service, the upkeep of it, and the continual development. But as they're doing this, they also need to be able to see what affects these services as well. So we've got views for them to be able to think, hey, I don't want to be a Kubernetes expert, but I still want to know what's going on with my services. So as a developer team, maybe I get to see the issues that have occurred on my service or my workloads over a period of time. I get to also see how well I'm doing from an optimization or a cost optimization standpoint. It's telling me maybe I can increase that score a little bit more. But we're not here to really talk about increasing the score here because right now what we want to see more of is how we can ensure like that continuous reliability. So what we can see immediately is we've got availability issues with several of our services. We've got this correlation engine here. This correlation engine service is a deployment that has had a number of issues. And I'm just going to make my screen a little bit larger so I can see a little bit better. It's had a number of issues over a period of time, right? Over the last 24 hours, we've seen some things have gone on. We have a deployment that's gone on without an image change. There's an availability issue. PagerDuty and Datadog have even told us some bits and pieces about what's going on. But maybe I'm just doing some testing. And what's really cool is I've got an events timeline that I can go back in time, kind of like a time machine, to see what actually happened during that period of time between 11:20 at night and 2:15 in the morning. And I can even go a little bit further and troubleshoot this, but maybe I'm not there yet. Maybe I have some Kubernetes expertise and I want to see if the logs might tell me something here, or maybe I want to go dig into some of these pods and see what might be going on with some of these pods. And what's really cool is as a developer, maybe I want to see the details of this pod as well and see if there's something that might be different, might be off. Maybe there's a label on here that caused it to fail. Maybe there's a config map that might have caused it to fail as well. And then maybe I also need to see what other services might be affected or could be affecting this one little service as well. So what's really cool is I have a lot of data, a lot of meaningful data that helps me as a developer just figure out what's going on. And when you think about the different teams and dynamics that exist in various organizations, you've got these self-serving teams that just want to jump in and use Kubernetes and deploy applications. And then you've got another team that has to deal with the ramifications of that. When things go wrong, well, what happens? Well, they're the ones that are responsible to take on tickets. And so the correlation here is that as there are more devs using Kubernetes, that ticket count can increase. But we can help with that. We flip that conversation a little bit in different ways. We actually turn it around and say, well, if you're going to use Komodor, bring more devs. Like just add them into the conversation, and simultaneously they'll be enabled to use Kubernetes a little bit better. And in fact, they can even get to the extent of starting to troubleshoot their own issues. What does that mean? Less tickets overall. If some of this is in production and you have service owners here, well, if they're solving the issues themselves and they can roll back very quickly, well, on their end, from their point of view, well, look, they've been unblocked. They can solve their issues quickly and move on and continue to iterate on their code and applications and add more features. For the operators, less tickets. That metric is important because there's less that they have to be worried about. Now they can focus in on other areas around innovation, around capacity planning, around expanding the infrastructure, around growing the footprint, around addressing other larger availability issues. Now, I'm a developer, right? I don't know Kubernetes. I don't want to know too much about it, but I want to solve the problem of Kubernetes. I want to solve the issue of what's actually going on with my service. And so maybe I'm doing a little bit of learning here. I'm learning a little bit about what an OOM killed error or an out of memory killed error is when a service just runs out of memory because it's trying to do something consistently. It's trying to make calls consistently, or it's trying to hit a particular limit consistently, and it's going to, you know, grow its memory footprint to the point that maybe it falls over, to the point that maybe the node that it runs on falls over. That's a reliability issue. Now, if your developers can solve this problem before it even hits your infrastructure, they've at this point saved you from an outage, from a larger outage for that matter. So you're simultaneously empowering them to be a little bit more specific. So let's go back to this dependency mapper, right? This is a network mapper. This is telling us who's talking to who and who should be talking to who and who is being affected by this one service being down and out. And maybe we might want to dig into the logs a little bit more. But let's be real, right? Who wants to actually comb through log line after log line after log line, especially when none of it makes sense? And so what we've done is we've actually just done some really cool engineering work here and paired with an LLM and created some prompts that say, look for these things, look for these particular error messages, or look for these like trends or patterns. And if you find this, well, tell us about it. We want to know. And in this particular case, well, there's an API rate limit that's set to be larger than the acceptable match size. And when we're trying to hit that API rate limit, or when we're trying to just keep making those calls, well, guess what? We're going to exhaust our memory for that particular service. And so it's pointing us to a particular config change where it's telling us that there has been changes made in Git, and it might even be tied to a specific config map change altogether. In fact, it might even be, if we look further down, we might even see what those changes might have been. I don't see the changes here. Let's look elsewhere. Let's see where else those changes might exist. Let's see, changes here. Do we see any config map changes that I'm looking for? No, not here. Well, we see that the replicas were increased, but we're noticing who gets affected, right? We're noticing that there are availability issues being caused by out of memory issues. We're noticing that overall, like until we actually fix the problem or achieve a resolution, which might even be the case of, hey, we actually might need to set a guardrail in place. What that guardrail might need to be is maybe I need to set a memory limit this prevents the actual pod from overusing the amount of resources available inside of a cluster. That leads to the stability of your nodes. So if you think about it, here, let's back up a bit. Let's actually look at it from a different lens. We've got degraded services as well. We can even look at this from an all workspaces overview. Degraded services, interestingly enough, there's different lenses to look at, different ways to look at this. Degraded services can be affected by noisy neighbors. So if we think about it, right, I was talking about one service that was causing issues. Well, we found out quickly here, this one service is consuming 8 gigs of RAM. Maybe our service doesn't need 8 gigs of RAM. There's a misconfiguration that's causing it. And so we need to come in here and put a memory limit. There's probably something code related that's actually broken. We need to go back in and fix it. But we could start here. Set a limit so that the node itself doesn't fall over. But if we don't set that limit for the memory, guess what happens? Another 219 workloads get affected, which means your entire application set could be down because of this one service, this one noisy neighbor. Let's look at it. Let's look at reliability from a different lens for a second. Now, if we're thinking about upgrades, right? We're thinking about upgrades from the lens of, I see that Kubernetes is going to be deprecated very soon, and I need to do something about it. Well, let's say I'm using, okay, well, you can already see here, we're using maybe 1.22 or we're using 1.24. What was the version that came up here? 1.26. This is the version that we're currently running. Well, 1.30 came out, right? 1.29 was the most recent version, 1.28, 1.27. So that's 3 versions or 3 revs behind. 1.26 is a little too old. And now we've actually hit some compliance issues, fallen out of compliance. So that affects us in different ways. But now we also have to think about the fact that, well, we've got a huge jump to make. If we make that jump with the one-click upgrade, how many custom resources are we breaking? What are we doing to the Istio Ingress gateway? What do we have to do? Well, something's changed actually between 1.26 and 1.30. For example, there were some enhancements to the gateway API spec and the way you could choose whether you're going to use the Ingress gateway or the gateway API for Kubernetes when you're using Istio. So to think about those things for a second and what actually breaks, how many things you have to go back in and fix, well, now you have this foresight. Now you're being a little bit more proactive and ultimately increasing the reliability metric altogether. So to wrap up, right, like when we think about reliability, we're not thinking just about the fact that we've got to right-size our workloads. We're thinking about the fact that we're continuously monitoring these workloads because their requirements change over time. And we begin to see that as we scale workloads up and down, and when we change even the application code itself, those requirements change the right sizing of our workloads as well, which actually then becomes a reflection of the way we right size our environments, our infrastructure. But then we also have to think about that interoperability for a second. We have to think about all the moving pieces. What happens when a cluster is about to reach its end of life and we have to go out and upgrade a bunch of APIs? Because if we don't, well, the configurations that we might have already deployed, like a pod security policy, for example, why are we still running that? We shouldn't be running that. We actually have to remove that before we continue to upgrade or even run in production, especially if we're going to jump to 1.30. In fact, at that point, if you're making such a huge jump, you have to sit there and assess. Maybe you do a stepped upgrade. And this is going to walk you through all the different changes, all the different API changes or the CR changes that have occurred over that period of time. So it's not just about thinking around, right sizing, the APIs that change. It's about thinking holistically around the different data sources that you have, the different sources of information that you have access to, and then enabling your developers to then consider the fact that, hey, I have a platform that I can log into, jump in, quickly and easily solve my own problems and unblock myself, but also reduce the cognitive burden or load for my operational teams to have to come in here and solve the problem for me. And then on the ops side, well, I've got a consolidated platform that I can see all my clusters, see all my workloads, scope workloads and services down to the developers and the teams that need to see them, and then enable them to just be a lot more self-serving, which is a reflection of a reduction for my MTTR in turn. So the Komodor platform is going to help you with your continuous Kubernetes reliability, because guess what? We understand the right flexibility and the perfect marriage between right-sizing your workloads and the workload operations without any sort of performance trade-off. We understand Kubernetes really well. Heck, we've worked with Kubernetes for so long that we've understand it intrinsically enough, understand where it can start to fail, that we're telling you, this is how you should be operating Kubernetes. And we're even giving you the platform to be successful with Kubernetes at scale as well. So going back to the presentation here for a second, and also checking to see if there are any questions that might have come up. I don't see anything in the QA. I don't see any. Oh, there is a question here. Does the features showing up in this demo are available in the freeware of Komodor? Also, is there any parameter or doc or something which shows that Komodor is a trusted software? So I can answer that question, but I'm going to let Udi answer it. So feel free to come on board, Udi.
All right. Thanks, Marino. And thanks for that question. So I will answer the second one first. So a trusted software, we have SOC 2 certificate that you can see on our website. If you go down to the footer, you will see all of that information regarding security compliance, GDPR, what APIs we use, everything you need to know to be rest assured. Although you will be, oh, perfect. Thanks, Marino. If you can go to the Komodor website for a second. To be honest, once you see the logo strip at the start, you should be, if you scroll down a bit, Marino, once you see those logos up there, you can be rest assured that we are a trusted software, since we have banks, fraud prevention companies, huge enterprises like Rockwell Automation, and other big companies that you may know of, like Priceline, OpenTable, and others that are not on this list. If that does not suffice, you can scroll all the way down. And there it is.
There.
So if you go to our website and follow all the way to the footer, you will find all the information you want to know. Also, as you can see, you can book a demo and meet with one of our experts like Marino and discuss your particular use case and what you are more concerned about. Now, to your first question, Marino, if you can scroll just a tiny bit up. Here you can see, and slightly down, yeah, stop. So we have 3 awesome open source projects. ValidateCube, which is a combination of a few scanning tools for YAML files to detect misconfigurations, security risks, and just general YAML hygiene. That's ValidateCube. And Helm Dashboard is my personal favorite and our most successful open source project. It is a dashboard, a GUI for Helm, which helps you manage your Helm charts, know when it's time to upgrade, gives you an option to quickly roll back, compare charts, and all the things you want to do in Helm in a visual way. Komoplane is similar, but for cross-plane. It's not as robust as Helm Dashboard. And unlike Helm Dashboard, it's a standalone open source project and not part of the commercial product just yet. So those are our open source projects. They are free, and you should check them out and contribute if you want to. The actual Komodor platform that Marino just demoed has a 14-day free trial, and you are welcome to check it out for yourself. If 14 days don't suffice and you want an extra time to evaluate, just reach out through the in-app chat on the intercom and tell us your story, and we'll be happy to extend it for you. Just say Marino sent you.
Awesome.
For pricing for like the extended things, better to talk. So you can find the means to reach us here in the QR or on the website.
Exactly. So if you want to link to this presentation, the first QR code, just, scan that and you've got full access to this presentation. Feel free to, share with your team, or we'll share the recording to this later on as well. And then connect with us, right? That second QR code will allow you to get in touch with us. And if you've got questions about Komodor's platform, or if you even want to try it out, you're welcome to. So I want to thank you all for your time, for coming out to this webinar. If you have any more questions, you know where to find us. We're here for you. Udi, any last thoughts?
I just want to say thank you, Marino, for hosting this workshop masterfully. And thank you so much for everything that you do outside of Komodor for the community, and especially for what you are doing with Komodor today. It was an amazing session, really insightful, and I hope people found it just as good. The concept of continuous reliability is something that's still new for a lot of people, and you explained it really masterfully, and I'm sure we're all wiser thanks to that. One final note before we let everyone go is that our next webinar is next month on June the 26th. We will have a different topic, a different presenter, but it will be just as great. So thanks everyone for joining. Thank you, Nikki.
Thank you, Udi. Thank you, Marino.
Thank you, Marino.
Thank you to all of you here.
Bye.
Bye.